We now continue discussing the code for root mean squared error. I want to elaborate on one particular line. So this will illustrate a concept called implicit type conversion, and we also touch on integer overflow. So if we carefully look at this line, we realize there's actually a type mismatch. So price is an int, and it's a predict function return an integer. So the expression on the right hand side of this assignment statement will give an integer value. So it's an integer minus integer. But the variable ERR error have a double type. So what happens is the compiler will add code to automatically convert a int value to a double value. And this happens automatically because the double can represent a bigger range than int. So this will happen by itself. You don't need to tell the compiler to do the conversion. So the compiler will does it automatically. So an interesting question is, because here we're still essentially having an integer value. So can we declare this error variable, instead of declaring to be double, we declare it to be int. And then the code will look like this. So then we will compute error squared, error times error, and then this will be added to the double value. So then the implicit conversion will happen a little bit later, and happen at this the last line on this slide. So the question is, would that be fine? I encourage you to try it in your code. So essentially, just change this double in int in the standard code and see how it works. And the answer is so I encourage you to pause this video and try it out and see what it is. So if you have tried, you probably saw the answer would be incorrect. And the reason is there will be an integer overflow occur here. So earlier we said integer can represent the largest integer value that can be represented using int type is this, roughly 2 times 10 to the 9. So when the error is larger than or equal to 48341, then this squared will be larger than that. So we'll have an overflow, and what happens is the overflow will result in this being a negative value. So essentially it won't be an accurate. So if you have overflow, then you won't get the correct result. And the reason is if we look at the last statement, so error is the integer, this error is integer. So when we are doing the multiplication, the compiler doesn't know these how this value will be used. So this error times error is treated as integer calculation. So then the overflow will occur, and then when we add this number to sum a, then we will convert that into double. But at that point, the number is already negative, and then we'll convert essentially a negative number into double. So to illustrate this, we really should run some code. So this is a kind of complicated version of the code that you can try. But let's start with something easier. So this is the code I already typed. So I have assign 46340 to error, and then we print out error squared, error times error. So and then we add 1 to error, and then we print the same thing again. So let's look at what's this print. Let's add end of line to make the looks better. Okay, so we have 46340 times 4640 equals this guy, and then the next line have 46341 squared will be a negative number. So then we can see the impact of when we add this. It will still be negative number. So I want to show this. So we will actually, let's just do assignment instead of add equal. If we do this assignment here, even so let's just print sum1 and sum2 at the end. So we print sum1 yeah, so this is just to show that even though we are assigning this value to a double, the overflow will still occur. Okay. Oh, this is where I missed my semicolon. Yeah, so they indicate compiler error at 11, but it's sort of slightly before that where the error occurs. Yeah, so I think, yeah, this is interesting. As you can see, the way these are printed out, this is the default format. It uses this I guess this is scientific notation for numbers instead of the two. I guess it is different 1474, 14748. So yeah, one positive, one negative. So the sum2 will be a negative number. So of course, if we do the fixed, let's just try. If we just do fixed without setting precision, what would be the result? Okay, so default precision is 6. I guess it's a 6 digit, 6 decimal places. So we have a positive number and have a negative number. Now, so what happens if we want to avoid this then we can do this. We can do sum3 equals, we can do a few things to convert this into double first. So yeah, so this is one way to do it. So we first add 0 to error, and because 0.0 is a double value, so whenever there's a decimal point, this is treated as a double value. So then this, we are adding a double value and an integer. This will convert this result into a double. So we'll convert error into double and then add it. And then we're multiplying a double with an integer. That result will also be double. So let's see sum3. Let's see what this gives us. Missed one of these. Okay, so as you can see, the sum3 is correct. So it's a positive, or I guess we can add. So instead of doing that 0.0 plus, another way to do it is 1.0 times this. So let's see what this should give us. 1 correct. Okay, so yeah, this print this as a correct value, except that the fixing happened later. So let's move this fixing earlier here. So that should print. Okay. So now we see this square is a correct value. By putting a 1.0 here, we convert this calculation, the whole calculation, into double. Then we don't have an overflow. Okay. Yeah, so this code roughly do that. So you can sort of play with this code yourself to understand the effect of conversion and overflow.